Picture yourself sitting in the cramped cockpit of a Mitsubishi A6M0 somewhere over the vast expanse of the Pacific Ocean in 1943. You're a pilot for the Imperial Japanese Navy, and for what feels like an eternity, you've owned these skies. The Zero you're flying has been the undisputed master of aerial combat since the war began. It's nimble, quick to respond, and in the hands of a skilled aviator like yourself, it's been practically untouchable. You've watched enemy planes fall from the sky, their pilots no match for the superior maneuverability and range of your aircraft. The Americans, the British, the Dutch, none of them had anything that could truly challenge you when this war started. But something has changed, and you can feel it in your bones every time you take to the air now. There's a new presence in the Pacific skies, something different from anything you've encountered before. It's an American fighter, and it's rewriting all the rules of engagement that you've come to know and trust. This aircraft doesn't dance around you like the earlier American planes tried to do, attempting to match your Zero's agility. No, this one comes at you with a completely different strategy. It's faster than your Zero, significantly so. When you try to dive away or climb to escape, this American fighter stays with you, relentlessly hunting. It's built like a fortress, shrugging off damage that would send your lightweight Zero spiraling into the ocean. And when its guns open up, the volume of fire is absolutely devastating. Within just 12 months of this new fighter's appearance in combat, everything you knew about air superiority has been turned completely upside down. The skies that once belonged to Japan are now contested, and increasingly they're being dominated by this American aircraft. Your fellow pilots are disappearing at an alarming rate, and the ones who return tell stories that chill you to your core. This isn't just another fighter plane. This is something that was specifically engineered to hunt and destroy everything you're flying. The Americans called it the Hellcat, the Grumman F6F Hellcat, to be precise. Now, if you were to see this aircraft sitting on a carrier deck or taxiing down a runway, you probably wouldn't be immediately impressed by its aesthetics. This wasn't a plane that won beauty contests. There was nothing particularly graceful or elegant about its silhouette. In fact, if you had to describe it honestly, you'd say it looked rather utilitarian, perhaps even chunky. Some observers compared it to a flying brick, a description that wasn't entirely unfair given its stocky, muscular appearance. The Hellcat didn't have the sleek lines of some of its contemporaries. It wasn't trying to turn heads with artistic design flourishes. But here's the thing about flying bricks. When they're engineered correctly, when they're built with purpose and precision, they can be absolutely devastating in combat. And the Hellcat was engineered very, very correctly. Appearances, as it turned out, were completely deceiving in this case. That ungainly-looking aircraft would go on to achieve something truly remarkable in the history of aerial warfare. Over the course of the Pacific War, Hellcats would be credited with destroying more than 5,000 enemy aircraft. That's not a typo. 5,000. To put that in perspective, that's more aircraft than any other Allied fighter managed to shoot down during the entire war. No Spitfire variant, no Mustang, no Thunderbolt, no other aircraft on the Allied side could match that tally, but raw numbers only tell part of the story. What's even more impressive, what really demonstrates the Hellcat's dominance, is its kill-to-loss ratio. For every Hellcat that was shot down in combat, 19 enemy aircraft were destroyed, 19-1. Let that sink in for a moment. In the brutal mathematics of aerial combat, where ratios of 3 or 4-1 were considered excellent, where 5-1 was considered outstanding, the Hellcat achieved 19-1. This wasn't just superiority, this was absolute domination on a scale that had never been seen before and hasn't been matched since. You can search through the entire history of fighter aviation, from the biplanes of World War I through the jet fighters of the modern era, and you won't find another aircraft with combat statistics like that. Now here's something that makes the Hellcat story even more remarkable. This wasn't a fighter that had been in development for years, carefully refined through numerous prototypes and extensive testing. The timeline for the Hellcat's development and deployment was absolutely extraordinary, especially when you consider the complexity of designing and building a successful fighter aircraft. The design process began in earnest. The prototype took to the air for its first flight in 1942, and by the summer of 1943, less than 2 years after the project really got rolling, production Hellcats were already engaging in combat missions over the Pacific. That's an incredibly compressed timeline for developing what would become one of the most successful fighters in history. This rapid development wasn't an accident or a matter of luck. It reflected the desperate urgency that characterized American military production in those early years of the war. When the United States entered World War II after Pearl Harbor, the nation found itself in a precarious position in terms of carrier-based fighter aircraft. The planes currently in service, while flown by brave and skilled pilots, were clearly outmatched by the Japanese Zero in several key performance areas. American strategists and engineers understood with crystal clarity that time was not a luxury they possessed. Every month that passed without a fighter capable of challenging Japanese air superiority meant more losses, more setbacks, more ground that would have to be reclaimed at terrible cost. Grumman Aircraft Engineering Corporation, which would later become famous for building some of the most rugged military aircraft in history, took on this challenge and delivered beyond anyone's most optimistic expectations. They didn't just produce a fighter that could compete with the Zero, they created one that could dominate it completely, and they did it in record time. The company's engineers worked with an intensity and focus that was driven by the knowledge that American sailors and Marines were dying in the Pacific, and that the fighter they were designing could be the difference between victory and defeat in the island-hopping campaign that was about to unfold. At the heart of the Hellcat's fearsome performance was its engine, and what an engine it was. Grumman selected the Pratt & Whitney R2800 Double Wasp, an 18-cylinder, 2-row radial engine that would become legendary in its own right. This wasn't just any power plant. The R2800 was one of the most reliable, most robust aircraft engines ever manufactured. It would go on to power numerous famous aircraft during and after the war, but in the Hellcat, it found one of its perfect applications. The Double Wasp could produce 2,000 horsepower, an enormous amount of power that gave the Hellcat capabilities that the lighter Japanese fighters simply couldn't match. With that massive engine up front, the Hellcat could reach speeds of 380 miles per hour in level flight. Now, that might not sound like it would be overwhelming compared to the Zero's maximum speed, but speed was just one part of the equation. What really mattered was what the Hellcat could do with that speed across the entire flight envelope. It could dive faster than a Zero without the risk of structural failure. It could climb powerfully, maintaining speed and energy in vertical maneuvers, and critically, it could sustain high-speed flight while carrying a combat load that would have been impossible for lighter fighters. And what a combat load it was. The Hellcat came equipped with 6 Browning M2 heavy machine guns, chambered in .50 caliber. These weren't light machine guns. The .50 caliber Browning was a devastating weapon that could punch through aircraft structures, engine blocks, and light armor plating with ease. Having 6 of them meant that when a Hellcat pilot got an enemy aircraft in their gun sight and pulled the trigger, the target was being hit with an absolutely withering storm of large-caliber bullets. The volume of fire was simply overwhelming. Japanese aircraft, which were often lightly built to maximize performance and range, stood little chance when caught in that fusillade. But the Hellcat wasn't just a fighter in the traditional sense of the word. Its robust design and powerful engine meant it could carry additional ordnance that expanded its mission capabilities dramatically. Pilots could load rockets under the wings, turning the Hellcat into an effective ground attack aircraft that could strike at enemy installations, ships, and troops. It could also carry bombs, not just small anti-personnel weapons, but substantial bombs that could damage or destroy significant targets. This versatility meant that a carrier air group equipped with Hellcats had incredible flexibility in how it could be employed. The same aircraft that was sweeping enemy fighters from the sky in the morning could be attacking ground targets in the afternoon. The Hellcat was, in effect, a flying tank, but one that could also soar through the air at high speeds and outfight anything it encountered. The combination of firepower, speed, durability, and versatility created a package that was greater than the sum of its parts. This wasn't an aircraft that excelled in one area while being mediocre in others. It was genuinely excellent across the board, which is extraordinarily rare in fighter design. Usually, aircraft design involves compromises, trading performance in one area to gain advantages in another. The Hellcat somehow managed to minimize those compromises to a degree that few aircraft before or since have achieved. There's an aspect of the Hellcat's design philosophy that often gets overlooked when people focus on its impressive combat statistics and specifications. But it's absolutely crucial to understanding why this aircraft was so successful. The Hellcat was deliberately designed to be easy. Easy to fly, easy to maintain, easy to repair, easy to survive in. This might sound like a simple or obvious goal, but it represents a profound shift in thinking about fighter aircraft design, and it made all the difference in the world when it came to actual combat effectiveness. Let's start with ease of flying. The Hellcat had forgiving flight characteristics that made it accessible to pilots with relatively limited experience. In the early years of the war, American pilot training programs were being rapidly expanded to produce the large numbers of aviators needed for the massive carrier fleet that was being constructed. Many of these pilots were young men who had never flown anything before entering the service, and their training time, while intensive, was still compressed compared to the years of experience that some of the veteran Japanese pilots possessed. The Hellcat was designed with these less experienced pilots in mind. It was stable in flight, predictable in its responses, and didn't have dangerous or tricky handling characteristics that could catch an inexperienced pilot off guard. This meant that a pilot who had trained on the Hellcat for a reasonable but not excessive amount of time could climb into the cockpit and still hold their own against Japanese aviators who had been flying combat missions since the war began, or even before. The aircraft compensated for the pilot's lack of experience through its own inherent qualities. Its speed meant you could break off an engagement if things went badly. Its firepower meant that even a brief opportunity to shoot could be devastating. Its durability meant that mistakes that would be fatal in other aircraft might be survivable. The Hellcat gave its pilots a fighting chance from day one, and as those pilots gained experience, they became truly formidable in this already formidable machine. Maintainability was another area where Grumman's engineers showed their wisdom. Carrier operations are incredibly demanding on aircraft. The environment is harsh. Salt air corrodes metal, constant motion stresses components, and the violent impacts of carrier landings create wear and tear that land-based aircraft never experience to the same degree. Moreover, the space available for maintenance and repairs on an aircraft carrier is limited, and the tools and equipment available are what can be carried aboard ship. The Hellcat was designed from the beginning to be maintained and repaired in these constrained conditions. Components were designed to be accessible without requiring the aircraft to be extensively disassembled. Parts were standardized where possible, reducing the variety of spares that needed to be stocked. The rugged construction meant that things broke less frequently in the first place. The result was an aircraft that could maintain a high operational readiness rate even during intensive combat operations. Carriers could launch more Hellcats more often because more of them were flyable at any given time. This operational availability was a force multiplier that doesn't show up in the specifications or the kill ratio statistics, but it was absolutely vital to the Hellcat's effectiveness. What good is the best fighter in the world if it's constantly down for maintenance and unavailable when you need it? Survivability was perhaps the most important aspect of the Hellcat's design for the pilots who flew it. Fighter combat is inherently dangerous, and no amount of engineering can make it safe, but the Hellcat was designed to give its pilot the best possible chance of getting home even when things went terribly wrong. Consider carrier landings, which are among the most demanding and dangerous maneuvers in all of aviation. A carrier deck is a moving target, rising and falling with the ocean swells. It's short, requiring the aircraft to catch an arresting wire to stop in time. The descent rate at touchdown is significant. essentially a controlled crash onto the deck. In many aircraft, a landing that was even slightly off, coming in too fast, at the wrong angle, or with too high a sink rate, could result in catastrophic damage to the aircraft or injury to the pilot. Landing gear could collapse, the aircraft could bounce uncontrollably, or structural components could fail. The Hellcat, by contrast, was built to absorb punishment. Its landing gear was incredibly strong and well designed. Its fuselage structure could handle high-impact forces without breaking apart. Pilots quickly discovered that the Hellcat could tolerate landing mistakes that would have destroyed other aircraft. It would hit the deck hard, bounce perhaps, but then settle down and catch the wire. The aircraft would shake it off, and after inspection and any minor repairs needed, it would be ready to fly again. This ruggedness saved countless lives and aircraft. A pilot who had a rough landing didn't have to worry as much about dying or destroying their aircraft. They might get chewed out by the landing signal officer, but they'd walk away, and their Hellcat would likely fly again. This took a huge psychological burden off pilots during carrier operations, allowing them to focus on the tactical aspects of their missions rather than being paralyzed by fear of the landing. The psychological impact of the Hellcat extended far beyond its own pilots. Japanese aviators, particularly those who survived encounters with Hellcat squadrons, quickly developed a healthy respect for, and often a deep fear of, this American fighter. The experience of facing Hellcats in combat was utterly different from what Japanese pilots had encountered earlier in the war. When they had fought against Wildcats or other earlier American fighters, they could often rely on their Zero's superior maneuverability to outfight their opponents, even when outnumbered. The tactics that had worked for years, the combat doctrines that had been developed through hard experience, all of those still gave them a fighting chance. Against the Hellcat, those old advantages disappeared. The American pilots might not try to dogfight in the traditional turning, twisting combat that favoured the Zero. Instead, they'd use their superior speed and power to dictate the terms of engagement. They'd dive in from above with tremendous velocity, their 650s blazing, shredding the lightweight Japanese aircraft with devastating fire. If a Zero pilot tried to evade by turning, the Hellcat pilot might not follow them into the turn. Instead, they'd use their superior speed to zoom climb back to altitude, then come around for another high-speed pass. If the Japanese pilot tried to run, the Hellcat was faster and would simply run them down. When Hellcats appeared in numbers, which they increasingly did as production ramped up and more carriers joined the fleet, the situation became absolutely nightmarish for Japanese pilots. Imagine looking up and seeing not one or two, but a whole squadron of Hellcats diving down at you. The sky would seem to fill with them, and suddenly you'd be in the middle of what could only be described as a wall of fire. 6 machine guns on each aircraft, multiple aircraft attacking from different angles. The combined firepower was simply overwhelming. Rockets would streak in, leaving smoke trails through the air. Bombs would fall if there were surface targets mixed in with the aerial combat. The entire engagement area would become lethal in the most comprehensive way possible. Japanese survivors of these encounters, and there were increasingly few survivors as the war went on, spoke about the Hellcat with a mixture of respect and genuine fear. Some of them would later admit in post-war interviews and accounts that they feared the Hellcat even more than they feared the flashy Vought F4U Corsair, another excellent American fighter that often gets more attention in popular history. The Corsair was certainly a remarkable aircraft, with its distinctive inverted gull wings and powerful performance, and Japanese pilots respected its capabilities. But the Hellcat inspired a different kind of fear. Why? The answer came down to numbers and inevitability. Corsairs were often present in the battles, but Hellcats came in swarms. The vast majority of American carriers were equipped with Hellcat squadrons because the aircraft was specifically designed for carrier operations and was available in large quantities. When Japanese aircraft encountered American carrier groups, they were overwhelmingly likely to face Hellcats, and lots of them. The Corsair might have had a slight edge in some performance parameters, but the Hellcat was everywhere, flown by pilots who were increasingly well-trained and confident, operating in an integrated system that maximized their effectiveness. The psychological factor of facing Hellcats became cumulative. As more and more veteran Japanese pilots were lost in combat, pilots who couldn't be easily replaced given Japan's limited training capacity, the average experience level of Japanese aviators decreased. Meanwhile, American pilots were gaining experience, learning the capabilities of their Hellcats, developing tactics that played to the aircraft's strengths. The newer Japanese pilots found themselves facing American aviators who knew exactly what they were doing in aircraft that were superior in almost every meaningful way. Survival in these circumstances wasn't likely, and the Japanese pilots knew it. That knowledge, that awareness that engaging Hellcats probably meant death, took a terrible psychological toll that only worsened the material disadvantages Japan faced. The Hellcats' dominance in combat wasn't achieved solely through raw firepower and performance, though those were certainly crucial factors. There was a level of intelligent, thoughtful design that went into every aspect of the aircraft that made it not just powerful, but smart. Every design choice reflected lessons learned from earlier combat experience and a deep understanding of what would actually work in the brutal reality of carrier-based operations in the Pacific Theater. Consider the armor protection that was built into the Hellcat. Earlier in the war, Japanese aircraft design had prioritized range and maneuverability above almost everything else. This meant that Zero fighters had minimal armor protection for the pilot and critical systems. The philosophy was that the best defense was to not get hit in the first place, and the Zero's agility was meant to make it difficult to target effectively. This worked well when Japanese pilots had superior training and experience, but it meant that when a Zero did get hit, the results were often catastrophic. A few well-placed rounds could kill the pilot or destroy the aircraft. American designers learned from both their own painful early war experiences and from captured enemy aircraft. They understood that in the chaos of aerial combat, even the best pilot was going to get hit sometimes. Rather than accepting those hits as inevitably fatal, they set out to design protection that would allow the pilot and aircraft to survive battle damage. The Hellcat incorporated armor plating in critical areas, particularly around the pilot's position. This armor couldn't stop every threat. Heavy cannon rounds could still penetrate, but it provided meaningful protection against machine gun fire and shell fragments. A Hellcat pilot who got bounced or caught in a bad position had a much better chance of surviving the initial burst of enemy fire than a Japanese pilot in a Zero would have had in the same situation. The fuel system represented another area where smart design choices made a crucial difference. One of the most devastating vulnerabilities in any aircraft is its fuel tanks. Aircraft fuel is highly flammable, and when tanks are ruptured by enemy fire, the results can be immediately catastrophic. The fuel can ignite, turning the entire aircraft into a flying fireball. Even if it doesn't ignite immediately, fuel streaming out of ruptured tanks means the aircraft will soon run out of fuel and have to ditch, often far from friendly forces. Early in the Pacific War, American pilots watched in horror as their aircraft burned after relatively minor combat damage, while Japanese pilots had watched the same thing happen to their own aircraft countless times. The Hellcat's fuel tanks were equipped with a self-sealing design that represented a significant technological advancement. When these tanks were punctured by bullets or shell fragments, a special coating would swell up when exposed to fuel, creating a seal that would stop or dramatically reduce fuel leakage. This system wasn't perfect. A large enough hole or enough holes could overwhelm the self-sealing capability, but it was remarkably effective in the majority of combat damage scenarios. A Hellcat that took hits in its fuel tanks had a good chance of making it back to the carrier with its fuel system intact enough to complete the flight. A Zero, by contrast, with its non-self-sealing tanks, would often be doomed by similar damage, either burning up or running out of fuel far from home. The structural integrity of the Hellcat was yet another manifestation of this smart, survivability-focused design philosophy. The airframe was built rugged, with structural members and skin that could take tremendous punishment. Combat damage that would tear the wings off a more lightly built aircraft or cause catastrophic structural failure might merely damage a Hellcat, degrading its performance but leaving it flyable. Pilots brought Hellcats back to their carriers with battle damage that looked absolutely horrific. Huge holes in the wings, sections of the fuselage torn away, control surfaces shot to pieces, yet the aircraft held together and could be landed safely. Grumman Aircraft Engineering Corporation earned a nickname during the war that reflected this incredible ruggedness: the Iron Works. It was said that Grumman planes simply refused to die, and the Hellcat was the ultimate expression of that philosophy. The company's engineers had created an aircraft that could absorb punishment that would destroy other fighters and keep flying, keep fighting, keep bringing its pilot home. This reputation was well earned through countless instances of Hellcats surviving circumstances that should have been fatal and making it back to their carriers. The psychological impact of this ruggedness on Hellcat pilots cannot be overstated. Knowing that your aircraft can take hits and keep flying gives you a confidence that allows you to press attacks that you might otherwise break off. It reduces the paralyzing fear that comes from knowing that a single lucky shot from an enemy might doom you. It allows you to focus on the tactical situation and executing your mission rather than being constantly worried about whether the next burst of enemy fire will be the one that sends you down. This confidence, multiplied across hundreds of pilots and thousands of missions, translated into better combat performance and more aggressive, effective tactics. By the time the war reached its later stages, the Hellcat had evolved from being a new fighter type into the absolute backbone of American carrier aviation. It was everywhere in the Pacific Theater, flying from the decks of fleet carriers, light carriers, and escort carriers. Every major naval battle, every amphibious landing, every carrier strike against Japanese-held islands featured Hellcats in prominent roles. The aircraft flew in every significant engagement from the middle of 1943 onwards, and its presence was often decisive in the outcome. The Marianas Campaign provides a perfect example of the Hellcat's dominance at its absolute peak. In June 1944, Japanese naval aviation made a desperate attempt to halt the American advance in the Pacific by committing their carrier forces to a massive engagement that would become known to history as the Battle of the Philippine Sea. The Japanese threw hundreds of aircraft into the battle in coordinated waves, hoping that sheer numbers and the skill of their remaining experienced pilots could turn the tide. What they encountered instead was a slaughter so one-sided that American pilots and sailors would forever after refer to it as the Great Marianas Turkey Shoot. Hellcat squadrons, forewarned by radar and vectored into ideal intercept positions by fighter directors on the carriers and accompanying ships, tore into the Japanese formations with devastating effect. The Japanese aircraft, many flown by inadequately trained pilots, stood virtually no chance against the combination of American radar direction, superior aircraft, and increasingly experienced pilots. Hellcats shot down Japanese planes in such numbers that pilots struggled to keep accurate counts. When they returned to their carriers to rearm and refuel, they'd describe aircraft falling from the sky like leaves in autumn. Some pilots would claim 5, 6, or even more kills in a single mission. The Japanese lost somewhere between 300 and 400 aircraft over the course of the battle. The exact number is still debated by historians, while American losses were minimal in comparison. The Battle of the Philippine Sea effectively destroyed Japanese carrier aviation as an effective fighting force. The aircraft losses could theoretically have been replaced from Japan's remaining production capacity, but the pilot losses could not. Japan had lost not only the aircraft but the aircrew, and replacing trained pilots took time that Japan simply didn't have. After this catastrophic defeat, Japanese carriers would largely become floating decoys, unable to conduct effective offensive operations for lack of aircraft and trained pilots to fly them. The Hellcat squadrons that achieved this victory flew from their carriers, shot down their opponents in overwhelming numbers, and returned home to land safely on their floating airfields, ready to do it all again the next day if needed. As the American advance continued westward across the Pacific, the Hellcat remained at the forefront of the fighting. During the Philippines campaign, Hellcats provided air cover for the massive amphibious landings and naval operations that would liberate those islands from Japanese occupation. They struck at Japanese airfields, destroying aircraft on the ground and preventing them from ever becoming threats to American forces. They escorted strike aircraft attacking Japanese shipping, protecting the bombers and torpedo planes as they went about their deadly work. They intercepted Japanese aircraft attempting to attack American ships, shooting them down before they could reach their targets. The fighting at Iwo Jima and Okinawa, the last major amphibious campaigns of the Pacific War, saw Hellcats in action once again, performing all the same missions they had throughout the war, but now against increasingly desperate Japanese defensive tactics. By this point, Japan had begun employing kamikaze tactics on a large scale, sending pilots on one-way suicide missions to crash their aircraft into American ships. The Hellcats and their pilots had to intercept and destroy these attacks before the kamikazes could reach their targets. It was exhausting, demanding work. There were no enemy pilots trying to survive and fight another day. There were only desperate men trying to ensure that if they died, they'd take Americans with them. The Hellcats rose to meet this challenge, shooting down kamikaze aircraft by the hundreds, though inevitably some got through to strike their targets. Historians who study the Pacific War have long recognized that the Hellcats' contribution was absolutely crucial to the Allied victory. Some have gone so far as to argue that without the Hellcat, the entire island-hopping campaign would have been fundamentally different, longer, bloodier, and possibly requiring different strategies altogether. It's a compelling argument when you consider what the Hellcat enabled. It gave the Americans absolute air superiority over the invasion beaches, meaning that troops going ashore didn't have to worry about being strafed by enemy aircraft. It protected the ships that carried supplies and reinforcements, ensuring that the logistical pipeline remained open. It allowed American carriers to operate with relative impunity, projecting power deep into Japanese-controlled waters. Without the Hellcat, or with a less capable fighter in its place, every one of those operations becomes more difficult, more costly, and more time-consuming. Landing troops on a contested beach while enemy aircraft strafe and bomb them means higher casualties and possibly failed landings. Operating carriers within range of enemy air power without being able to effectively defend them means more ships sunk, more sailors lost. The cumulative effect of not having the Hellcat would have rippled through every aspect of the Pacific campaign, potentially adding months or even years to the war's duration and increasing casualties dramatically on both sides. The bottom line, the fundamental truth about the Hellcat, is this. It wasn't a pretty airplane, but it never needed to be. Beauty in aircraft design is nice, and there's something to be said for the aesthetic elegance of planes like the Spitfire or the Mustang, but the Hellcat was built for a different purpose. It was built to win, and win decisively, and win quickly. Every aspect of its design was oriented toward that single goal. It needed to dominate the skies over the Pacific, to destroy Japanese air power, and to do it in a time frame measured in months and years rather than decades. The Hellcat was, without exaggeration, the ultimate predator of the Pacific theater. It hunted Japanese aircraft with ruthless efficiency, racking up kill counts that no other fighter would match. It protected American forces from air attack, creating the conditions under which amphibious operations could succeed. It enabled the carrier forces to strike deep into enemy territory, projecting American power across thousands of miles of ocean. And it did all of this while being relatively easy to fly, maintain, and survive in, characteristics that allowed it to be produced and deployed in large numbers and operated by pilots with varying levels of experience. In less than 2 years from the first prototype flight to combat operations, this aircraft that looked like a flying brick had fundamentally altered the balance of power in the Pacific. The Zero, which had reigned supreme for so long, found itself outclassed in nearly every meaningful way. Japanese pilots who had once felt confident in their aircraft's capabilities now flew, knowing that encountering Hellcats meant they were probably going to die. The psychological impact of that shift, combined with the material reality of the Hellcat's superior performance, created a death spiral for Japanese air power from which there was no recovery. The Hellcat crushed the Zero not through some single miraculous characteristic, but through the combination of speed, firepower, durability, producibility, and ease of use. It was a complete package that addressed every aspect of carrier-based fighter operations. It could fight, it could survive, it could be produced in large numbers, and it could be flown effectively by the pilots America was training in their thousands. The Japanese had no answer to this combination, and by the time they might have developed one, it was too late. American forces were at their doorstep, and the war was already effectively decided. By giving the Allies complete control of the skies over the Pacific, the Hellcat achieved something that few weapons systems in military history can claim. It fundamentally determined the outcome of a major theatre of war. Without control of the air, Japan's island garrisons were doomed, unable to be resupplied or reinforced except at terrible cost. Without control of the air, Japan's fleet couldn't operate effectively, leading to the destruction of their capital ships and the end of their naval power. Without control of the air, Japan's home islands became vulnerable to bombing campaigns and eventually to invasion planning. The Hellcat wasn't just a fighter aircraft. It was the instrument through which the United States seized and maintained air superiority, and that air superiority was the foundation upon which all other operations were built. It was the warplane that ended Japan's dream of air dominance, a dream that had sustained them through the early victories of the war and that they had counted on to help them defend their conquered territory. When that dream died in flames over the Pacific, shot down by Hellcats in ratios of 19-1, Japan's strategic position became hopeless. And the Hellcat accomplished all of this with brutal, uncompromising efficiency. There was nothing fancy about how it won. It was simply better, and it exploited that superiority ruthlessly. It was faster, so it could choose when to fight and when to break off. It was tougher, so it could absorb damage and keep fighting. It was more heavily armed, so when it did fight, it won decisively. It was easier to fly, so more pilots could use it effectively. It was easier to maintain, so more of them were available for combat at any given time. Every one of these advantages compounded the others, creating an aircraft that was far greater than the sum of its already impressive parts. The legacy of the Hellcat extends beyond its impressive combat record. It represented a maturation of American aircraft design philosophy, moving beyond the pre-war focus on performance above all else toward a more balanced approach that considered the entire operational picture. The lessons learned from the Hellcat influenced post-war aircraft design, teaching engineers that survivability, maintainability, and ease of use were just as important as raw performance numbers. Many of the design principles that made the Hellcat successful, rugged construction, redundant systems, armor protection, self-sealing fuel tanks, became standard features in subsequent generations of fighter aircraft. The men who flew the Hellcat in combat have their own stories to tell, their own memories of what it was like to fly this remarkable aircraft into battle. They speak of the confidence it gave them, the feeling of sitting in a cockpit surrounded by armor plate with a 2,000 horsepower engine thundering away in front of them and 6 50-caliber machine guns at their command. They describe the satisfaction of diving on an enemy formation, watching their tracers converge on a target, seeing the results of their fire as enemy aircraft broke apart or burst into flames. They remember the relief of nursing damaged aircraft back to their carriers, making it home despite battle damage that would have doomed them in other fighters. They also remember their friends and squadron mates who didn't make it home because for all its advantages, the Hellcat couldn't make combat safe. Men still died flying Hellcats, shot down by enemy fighters or anti-aircraft fire, lost in bad weather, killed in accidents and operational mishaps. The 19-1 kill ratio meant that for every 19 Japanese aircraft shot down, one Hellcat was lost, and that one Hellcat almost always had a pilot in it. The Hellcat was an extraordinary fighter, but it wasn't invulnerable, and the men who flew it understood that every time they launched from a carrier deck, they might not make it back. but those men also understood that they had the best tools available to them for the job they'd been given. They knew that the aircraft industry back home, working around the clock in factories across America, was producing Hellcats by the thousand and shipping them to the Pacific as fast as they could be built. They knew that the engineers at Grumman had designed the Hellcat specifically to give them the best possible chance of completing their missions and coming home alive. They knew that when they went up against Japanese aircraft, they had every advantage that American industrial might and engineering excellence could provide. That knowledge was itself a kind of weapon, a source of confidence and aggression that made them more effective in combat. The ground crews who maintained the Hellcats have their own perspective on the aircraft. They speak of its ruggedness in terms of how it made their jobs easier, or at least more possible. They describe working on carriers in the middle of the Pacific, with limited tools and parts, often in harsh weather conditions, trying to keep aircraft flying. The Hellcat's design made that possible in ways that other aircraft might not have. When a Hellcat came back shot up, the ground crew could often repair it and have it ready for the next day's operations. When an engine needed maintenance, the procedures were straightforward enough that even relatively inexperienced mechanics could handle them. When parts wore out or broke, they could be replaced without having to disassemble half the aircraft. This maintainability meant that carriers could sustain high operational tempos for extended periods. During intensive operations, when sorties were being launched around the clock, the ability to keep aircraft flying made all the difference. A squadron with a high percentage of its Hellcats available for combat could overwhelm enemy forces through sheer numbers, while also providing redundancy in case of losses. The ground crews took enormous pride in their ability to keep the Hellcats flying, understanding that their work directly contributed to the mission's success and their pilots' survival. The production workers back in the United States who built the Hellcats also have a place in this story. At Grumman's factories, workers, many of them women who had entered the industrial workforce to replace men who'd gone to war, assembled Hellcats at a rate that would have seemed impossible in peacetime. They worked long shifts, building aircraft with a combination of precision and speed that reflected both the urgency of wartime and pride in their craftsmanship. These workers understood that the aircraft they were building weren't just products. They were weapons that would be used in combat, and American lives depended on them being built correctly. That sense of responsibility drove quality standards that ensured Hellcats arrived in the Pacific ready for combat, without the critical defects or shortcomings that might have compromised their effectiveness. Over the course of the war, more than 12,000 Hellcats were produced. 12,000 aircraft, each one a complicated piece of machinery with thousands of parts that all had to work together perfectly. The fact that American industry could produce them in such numbers while simultaneously building tens of thousands of other aircraft, along with ships, tanks, trucks, and every other kind of military equipment, demonstrated an industrial capacity that Japan simply couldn't match. Even if Japan had been able to design an aircraft equal to the Hellcat, which they never did, they couldn't have produced it in comparable numbers. The sheer scale of American production was itself a strategic weapon, overwhelming Japanese forces through the combination of quality and quantity. The Hellcat's success also reflected the larger American approach to the Pacific War. Rather than trying to match Japan at its own game, fighting the war according to Japanese strengths, American strategists played to their own advantages. They used industrial production to field better and more numerous equipment. They used technological innovation to develop capabilities that the Japanese couldn't easily counter. They used their logistical capabilities to project power across vast oceanic distances, maintaining supply lines that would have been impossible for Japan to sustain. The Hellcat fit perfectly into this larger strategy, being exactly the kind of aircraft that American advantages in industry and technology could produce, and that American logistical capabilities could deploy and maintain in the field. When the war ended in August 1945, following the atomic bombings of Hiroshima and Nagasaki and the Soviet entry into the war against Japan, the Hellcat's combat role came to a close. The aircraft would continue to serve in the post-war period, flying with the United States Navy for a few more years and serving with several Allied nations well into the 1950s, but its finest hour had been in the crucible of the Pacific War. In that conflict, it had proven itself beyond any doubt, achieving a combat record that would become legendary and that has never been surpassed. Looking back on the Hellcat's role in World War II, it's difficult to overstate its importance. This was the fighter that turned the tide in the Pacific Air War, that gave American forces the air superiority they needed to conduct their campaign successfully, that destroyed Japanese air power so thoroughly that it never recovered. Without the Hellcat, the war would have been different. How different exactly, we can only speculate, but certainly longer and costlier in American lives. With the Hellcat, American carrier forces could operate with confidence, knowing that they had the means to defend themselves and to strike at the enemy effectively. The Hellcat's success came from the perfect combination of right aircraft at the right time. It had the performance needed to dominate its opponents, the ruggedness to survive the brutal conditions of carrier operations, the reliability to maintain high operational readiness, and the production numbers to be available in overwhelming force. It was easy enough to fly that hastily trained pilots could be effective in it, yet capable enough that experienced pilots could use it to achieve extraordinary results. It was, in short, exactly what the United States Navy needed when it needed it, and it fulfilled that role with a level of success that exceeded even the most optimistic predictions. The story of the Hellcat is ultimately a story about how wars are won, not just through courage and sacrifice, though those are certainly necessary, but through the intelligent application of industrial and technological advantages. The Hellcat represented American engineering at its pragmatic best, creating a tool that was perfectly suited to its purpose and then producing that tool in the quantities needed to achieve victory. It wasn't the most beautiful fighter of the war, nor was it the fastest or the most maneuverable, but it was, arguably, the most effective, and in war, effectiveness is what matters. For the Japanese pilot imagined at the beginning of this account, sitting in his Zero in 1943 and watching his air superiority evaporate, the Hellcat must have seemed like an unstoppable force of nature. It came from a nation with industrial capabilities that Japan couldn't hope to match, flown by pilots whose numbers kept growing while Japanese pilot numbers dwindled, equipped with features and capabilities that Japanese aircraft couldn't replicate. The appearance of the Hellcat marked the beginning of the end for Japanese air power, and everyone involved, American and Japanese alike, knew it. That's the true measure of the Hellcat's impact. It didn't just win air battles, it changed the strategic calculus of the entire Pacific theater. It gave American forces a capability that Japan couldn't counter, and that capability enabled everything else that followed. The island-hopping campaign, the destruction of the Japanese fleet, the eventual victory in the Pacific, all of it was possible because the Hellcat had secured control of the air. That's a legacy that few weapons systems in history can claim, and it's a testament to the vision of the engineers who designed it, the workers who built it, the ground crews who maintained it, and the pilots who flew it into combat. The Grumman F6F Hellcat may have looked like a flying brick, but that brick smashed Japanese air power into rubble and paved the way for Allied victory in the Pacific. It did exactly what it was designed to do, and it did it better than anyone had any right to expect. That's not just success, that's excellence, achieved under the most demanding circumstances imaginable, when the stakes couldn't possibly have been higher. The Hellcat earned its place in history through brutal, efficient dominance, and its record of achievement speaks for itself across the decades that have passed since its guns fell silent. Understanding the context in which the Hellcat emerged requires looking back at the early days of the Pacific War, when American naval aviation found itself in a desperate situation. When Japan launched its surprise attack on Pearl Harbor in December 1941, catching the American Pacific Fleet at anchor and devastating it in a single morning, the United States found itself thrust into a war for which it was not fully prepared. The pre-war American military, while professional and well-trained, was relatively small and equipped with weapons that in many cases had been designed in the previous decade. The fleet carriers that would become so crucial to the Pacific campaign were few in number, and the fighters they carried were about to face a rude awakening. The primary carrier fighter at the time was the Grumman F6F Wildcat, a stubby, barrel-shaped aircraft that was tough and reliable but outclassed by the Japanese Zero in several key performance areas. The Wildcat was slower than the Zero, couldn't climb as quickly, and couldn't turn as tightly. American pilots flying Wildcats in the early months of the war had to develop specialized tactics to survive against their more maneuverable opponents. The Thatch Weave, named after Commander John S. Thatch, who developed it, became famous as a defensive maneuver that allowed Wildcats to protect each other through coordinated scissoring turns. These tactics worked and allowed skilled Wildcat pilots to hold their own, but they were fundamentally defensive responses to an aircraft that was simply better in a traditional dogfight. Meanwhile, the Japanese Zero had gained an almost mythical reputation. It had dominated the skies over China before the Pacific War began, and in the opening months of the conflict it seemed unstoppable. The Zero's combination of long range, lightweight, and exceptional maneuverability made it a formidable opponent, and Japanese pilots who had years of combat experience used these characteristics to devastating effect. Stories spread of Zeros outturning anything they encountered, of American and Allied pilots trying desperately to evade these nimble fighters and failing, of entire squadrons being shot down by smaller numbers of Zeros. This was the situation that Grumman's engineers faced when they began work on what would become the Hellcat. They needed to design a fighter that could not just match the Zero, but decisively defeat it, and they needed to do it quickly. Every day that passed without a superior fighter meant more American pilots dying in unequal combat, more carriers at risk, more strategic limitations on what the Navy could accomplish. The pressure to deliver was enormous, and the consequences of failure would be measured in American lives and potentially in the outcome of the war itself. Grumman approached the problem systematically, gathering every piece of intelligence available about the Zero and about combat conditions in the Pacific. They studied combat reports from pilots who had faced Zeros and survived. They examined wreckage of shot-down Zeros whenever it could be recovered. They talked to engineers and pilots about what was needed, what would work, what had failed. This intelligence gathering paid enormous dividends when American forces recovered an intact Zero from the Aleutian Islands in mid-1942. The pilot had crash-landed on a remote island, and while he didn't survive, his aircraft remained relatively undamaged. American forces transported this prize back to the United States, where it was thoroughly tested and evaluated. The captured Zero revealed both strengths and weaknesses. Its lightweight and efficient design gave it the maneuverability that had made it so feared, but that same lightweight meant it had minimal armor protection and non-self-sealing fuel tanks. It was fast enough in level flight, but its engine lacked the power for sustained high-speed operations or rapid climbs. Its armament, while effective, wasn't overwhelming. The testing revealed that the Zero could be beaten, but you had to fight it on your terms, not on its terms. You had to use speed and power instead of trying to outturn it. You had to use superior firepower to end fights quickly, rather than allowing prolonged dogfights where the Zero's maneuverability gave it an advantage. These lessons were incorporated directly into the Hellcat's design. Where the Zero was light, the Hellcat would be heavy but powered by an engine so strong that it wouldn't matter. Where the Zero was lightly armed, the Hellcat would carry 6 heavy machine guns. Where the Zero had minimal protection, the Hellcat would have armor and self-sealing tanks. Where the Zero required highly skilled pilots to use it effectively, the Hellcat would be forgiving and easy to fly. Every design choice was made with the specific goal of defeating the Zero in mind, creating an aircraft that would be the Zero's opposite in philosophy but superior in capability. The development program moved forward with remarkable speed. Wind tunnel testing, structural testing, engine integration, weapons installation, avionics integration, all the complex tasks that go into developing a new fighter aircraft were completed in a compressed time frame. Grumman's engineers worked around the clock, knowing that every week they saved in development meant the Hellcat would reach the fleet that much sooner. When problems arose, as they inevitably do in any development program, they were addressed immediately and pragmatically. There was no time for perfect solutions. Good enough solutions implemented quickly were better than perfect solutions that took months to achieve. The first F6F prototype took to the air on June 26, 1942, just 6 months after Pearl Harbor. The test pilots who flew it came back with positive reports. The aircraft felt solid and stable, with good control response and no dangerous handling characteristics. The big Pratt & Whitney engine provided tremendous power, and the aircraft's speed and climb rate were impressive. Some refinements would be needed, particularly to the engine installation and cooling system, but the basic design was sound. By October 1942, production had been authorized, and Grumman began setting up assembly lines to build Hellcats in large numbers. The production ramp-up was itself a remarkable achievement. Grumman's factories had to be reconfigured to build the Hellcat efficiently, with assembly line processes that would allow maximum production rates. Workers had to be hired and trained, many of them women who had never worked in manufacturing before, but who quickly became skilled at the precise work required to build aircraft. Supply chains had to be established to bring in the thousands of components that went into each Hellcat, from engine parts to instruments to the distinctive canopy that gave the pilot excellent visibility. Every aspect of production had to be planned and executed flawlessly to meet the Navy's urgent need for this new fighter. By early 1943, the first production Hellcats were rolling off the assembly line and being prepared for delivery to the fleet. Navy pilots began transitioning to the new fighter, learning its characteristics and capabilities. The feedback from these early pilots was overwhelmingly positive. The Hellcat was everything that had been promised: fast, powerful, heavily armed, and rugged. Pilots who had flown Wildcats marveled at the difference. The Hellcat felt like it had unlimited power compared to the Wildcat's relatively modest engine. The 650 caliber guns represented a massive increase in firepower. The armor and protection systems gave pilots confidence that they could take hits and survive. But all the testing and training in the world couldn't fully reveal what the Hellcat would do in actual combat. That would only become clear when Hellcats met Zeros in the skies over the Pacific, when theory met reality and design met the chaos of aerial warfare. The first combat deployment of Hellcats came in late summer 1943, and the results were everything American commanders could have hoped for and more. Hellcat squadrons engaged Japanese aircraft and started racking up kills immediately. The kill ratios were extraordinary from the very beginning, with Hellcats destroying multiple enemy aircraft for every loss. Japanese pilots found themselves in an untenable situation. Their Zeros, which had dominated the skies for so long, were now being hunted by an aircraft that was superior in almost every way that mattered. The tactics that had worked for years no longer worked. Trying to dogfight with a Hellcat was futile because the American pilot could simply use their superior speed and power to control the engagement. Trying to run was equally futile because the Hellcat was faster. The only real option was to try to avoid engagement altogether, but that meant ceding control of the air to the Americans, which was strategically unacceptable. As more Hellcats reached the fleet and more pilots gained experience flying them in combat, the American dominance only intensified. Squadrons developed tactics that maximized the Hellcat's advantages. They would typically approach combat at high altitude, giving them an energy advantage that could be converted into speed during a diving attack. They would attack in coordinated formations, with multiple aircraft focusing fire on individual targets. They would use their superior speed to extend away from combat when necessary, denying the enemy any chance to engage on favorable terms. These tactics, combined with the Hellcat's inherent superiority, created a killing ground in the Pacific skies. The impact on Japanese morale was devastating and cumulative. Early in the war, Japanese pilots had been confident, even cocky, knowing that their aircraft and their skills gave them significant advantages. By late 1943 and into 1944, that confidence had evaporated. Pilots going up against Hellcats knew they were probably not coming back. The psychological weight of that knowledge affected their performance even before combat began, creating a vicious cycle where fear reduced effectiveness, which led to more losses, which increased fear. The Japanese training pipeline, already strained by losses and unable to produce pilots with the same skill levels as earlier in the war, couldn't keep up with the attrition rate. Replacement pilots arrived at combat units with minimal experience and were thrown into battle against American pilots who were becoming increasingly experienced and confident. The technical evolution of the Hellcat continued even after it entered service. Grumman didn't just build the initial version and call it done. They continued to refine and improve the aircraft throughout its production run. Later variants incorporated upgraded engines, improved armament options, better radar equipment for night fighting, and numerous small improvements that increased capability and reliability. The F6F, which became the most numerous variant, featured a more powerful version of the R2800 engine, strengthened wing structure to carry heavier loads, and improved armor. These improvements kept the Hellcat competitive throughout the war, ensuring that it remained the best carrier fighter available even as the Japanese attempted to develop counters. One area where the Hellcat proved particularly valuable was in night fighting operations. Equipped with radar and flown by specially trained pilots, night fighter variants of the Hellcat could hunt enemy aircraft in complete darkness. This capability was crucial for defending task forces against night attacks and for interdicting Japanese transport and resupply operations that attempted to use darkness as cover. Night fighting in a single-engine fighter was incredibly demanding, requiring pilots to trust their instruments and their radar while hunting for targets they couldn't see with their eyes. The Hellcat's stability and easy handling made it suitable for this mission, and night fighter Hellcats scored numerous kills against Japanese aircraft that thought they were safe under cover of darkness. The ground attack role that the Hellcat could perform was another force multiplier that often gets overlooked when discussing its impact. Yes, the primary mission was air-to-air combat, and that's where the Hellcat made its greatest contribution, but the ability to transition to ground attack when enemy aircraft weren't present meant that Hellcats could contribute to the battle even when the skies were clear of Japanese aircraft. Hellcats attacked enemy airfields, destroying aircraft on the ground before they could take off. They struck at coastal defences before amphibious landings, suppressing anti-aircraft guns and strongpoints. They attacked shipping, using rockets and bombs to sink or damage Japanese vessels attempting to supply isolated garrisons. This versatility meant that carriers equipped with Hellcats could respond to a wide variety of tactical situations without needing to carry multiple specialized aircraft types. The relationship between Hellcat pilots and their aircraft often transcended simple professional necessity and became something more personal. Pilots gave their aircraft names, painted artwork on the fuselages, and treated their Hellcats almost like living entities. This personalization might seem trivial, but it reflected the deep trust and affection that pilots developed for an aircraft that was bringing them through combat and back home repeatedly. Many pilots became emotionally attached to specific aircraft, preferring to fly their Hellcat when possible, because they knew its specific quirks and characteristics. When these aircraft were damaged or lost, pilots felt genuine grief for the loss of a trusted companion. The ground crews similarly developed strong feelings about the Hellcats they maintained. They took pride in keeping their squadron's aircraft flying and in top condition. They worked in all weather, in difficult conditions, often with minimal sleep during intensive operations, because they understood that their work directly affected whether their pilots lived or died. A ground crew that did its job well meant aircraft that started reliably, guns that fired when the trigger was pulled, engines that didn't quit at crucial moments. The relationship between pilots and their ground crews was one of mutual respect and dependence. Pilots trusted the ground crews with their lives, and ground crews took that responsibility with utmost seriousness. The sheer scale of Hellcat operations by the war's end was staggering. On a single carrier, a typical air group might have 3 or 4 squadrons of Hellcats, with each squadron operating around a dozen aircraft plus spares. Multiply that across all the carriers in the Pacific Fleet, fleet carriers, light carriers, and escort carriers, and you're talking about hundreds of Hellcats operating simultaneously across thousands of square miles of ocean. Coordinating all these aircraft, maintaining them, supplying them with fuel and ammunition, providing replacement parts and entire replacement aircraft as needed, the logistical effort was enormous and represented yet another area where American organizational and industrial capability made the difference. Comparing the Hellcat to its contemporaries provides additional context for understanding its achievement. The P-51 Mustang, perhaps the most famous American fighter of the war, was primarily a land-based aircraft that excelled as a long-range escort fighter in Europe. It was an extraordinary aircraft in its own right, with performance characteristics that in some areas exceeded the Hellcats. But the Mustang wasn't designed for carrier operations and would have required significant modifications to operate from carriers. The Hellcat was purpose-built for the carrier environment from the beginning, with features like folding wings for compact storage, reinforced landing gear for carrier landings, and corrosion-resistant materials for the saltwater environment. The F-4U Corsair, the other famous American carrier fighter, had superior performance in some areas compared to the Hellcat, particularly in speed and rate of climb. However, the Corsair initially had significant problems operating from carriers due to its long nose and difficult landing characteristics. These issues were eventually resolved, and the Corsair went on to have a distinguished career. But the delays in carrier qualification meant that the Hellcat was there first and in larger numbers. The Navy's decision to deploy both types, rather than choosing one over the other, reflected the reality that having more capable fighters available was better than trying to pick a single best option. But the Hellcat remained the workhorse of the carrier air groups throughout the war. British and other Allied forces that operated from carriers in the Pacific also used Hellcats, with the Royal Navy in particular operating them in significant numbers. British pilots praised the Hellcat's ruggedness and reliability, finding it well suited to the demanding environment of carrier operations in the Pacific and Indian Oceans. The British Hellcats participated in operations against Japanese forces in Southeast Asia and the East Indies, contributing to the overall Allied effort to roll back Japanese conquests. The fact that the Hellcat was effective in the hands of pilots from different nations and air forces spoke to its fundamental soundness as a design. It wasn't an aircraft that only worked for American pilots with American training. It was an aircraft that worked, period. The Hellcat's combat record included some remarkable individual achievements by specific pilots who became aces flying the aircraft. An ace is defined as a pilot who has shot down 5 or more enemy aircraft, and the Hellcat created aces in substantial numbers. Many pilots who flew Hellcats achieved ace status in remarkably short periods, sometimes in just a few missions during particularly intensive combat operations. Some pilots went far beyond the minimum requirement for ace status, shooting down 10, 15, or even 20 or more enemy aircraft over the course of their combat tours. These top aces became famous, their names known throughout the Navy and celebrated in newspapers back home, but they always emphasized that their success was due in large part to the aircraft they flew. The Hellcat gave them the tools they needed. They just had to use those tools effectively. The training programs that prepared pilots to fly Hellcats were themselves remarkable undertakings. The Navy had to rapidly expand its pilot training capacity to produce enough aviators to fill the cockpits of all the Hellcats being produced. Training bases were established across the United States, particularly in areas with good weather that allowed for year-round flying. Student pilots progressed through a series of increasingly complex aircraft, starting with basic trainers and eventually advancing to the Hellcat. The training curriculum covered not just how to fly the aircraft, but how to fight in it: gunnery training, combat tactics, carrier landing procedures, navigation, instrument flying, and everything else a carrier pilot needed to know. The carrier qualification process was particularly demanding. Landing an aircraft on a moving carrier deck is one of the most difficult maneuvers in all of aviation, requiring precise control of speed, altitude, and approach angle. Student pilots had to demonstrate that they could do this consistently and safely before they were qualified for deployment with a carrier air group. The Hellcat's forgiving handling characteristics helped here. While carrier landings were never easy, the Hellcat's stability and strong landing gear meant that pilots could make mistakes and still walk away rather than crashing. This allowed training to proceed more quickly and with fewer losses than might have occurred with a less forgiving aircraft. Once qualified and assigned to a squadron, new pilots continued their training, now learning from experienced combat veterans who could teach them the specific tactics and techniques that worked in actual combat against actual Japanese aircraft. This sharing of knowledge and experience was crucial to maintaining the high effectiveness of Hellcat squadrons throughout the war. Veterans would take new pilots under their wing, literally and figuratively, flying as their wingmen in combat and talking them through engagements. This system ensured that hard-won lessons were passed on rather than having each new pilot learn everything from scratch and potentially paying for that learning with their lives. The impact of the Hellcat on the broader course of the Pacific War can be traced through the major campaigns and battles where it played a decisive role. At Tarawa in November 1943, one of the first major amphibious assaults in the Central Pacific, Hellcats provided air cover for the landing force, keeping Japanese aircraft away from the invasion beaches and supporting the Marines fighting ashore. The lessons learned at Tarawa informed subsequent operations, with the role of air support becoming even more refined and effective. At Kwajalein, Eniwetok, and throughout the Marshall Islands campaign, Hellcats dominated the skies, allowing the amphibious forces to operate with confidence that they wouldn't be subject to air attack. The Marianas campaign in mid-1944 represented the peak of Hellcat dominance, with the Battle of the Philippine Sea providing the most dramatic demonstration of its effectiveness. Beyond the famous Turkey Shoot air battle, Hellcats also supported the amphibious landings on Saipan, Tinian, and Guam, providing close air support for the troops fighting ashore and maintaining the air superiority that made those invasions possible. The capture of the Marianas was strategically crucial because it brought the Japanese home islands within range of American bombers, but none of it would have been possible without the air superiority that the Hellcat provided. The Philippines campaign saw Hellcats operating in support of General MacArthur's forces as they liberated those islands from Japanese occupation. The Battle of Leyte Gulf in October 1944, the largest naval battle in history, featured Hellcats in critical roles. They hunted for Japanese ships, attacked enemy vessels with bombs and rockets, and defended American carriers from Japanese air attacks, including some of the first organized kamikaze strikes. The complexity and scale of the Leyte Gulf operations demonstrated the maturity that American naval aviation had achieved, with Hellcat squadrons coordinating with other aircraft types and surface forces to achieve tactical and strategic objectives. As American forces moved closer to Japan itself, the fighting only intensified, and the Hellcat remained central to operations. Iwo Jima, needed as an emergency landing field for bombers returning from raids on Japan, and as a base for fighter escorts for those raids, was defended by Japanese forces who had months to prepare fortifications. The preliminary bombardment and the air support during the landing were crucial to American success, and Hellcats provided much of that support. Similarly, at Okinawa, the last major amphibious operation of the war, Hellcats flew thousands of sorties defending against kamikaze attacks, supporting troops ashore and maintaining air superiority over the invasion area. The kamikaze threat represented a different kind of challenge for Hellcat pilots than the traditional air combat they had been fighting. A kamikaze pilot wasn't trying to survive and fight another day. They were trying to crash into an American ship and destroy it even at the cost of their own life. This meant that conventional tactics of forcing an enemy to break off or retreat didn't work. The only way to stop a kamikaze was to shoot it down before it reached its target. Hellcat pilots had to intercept these attacks, sometimes at very low altitudes over the water, and destroy every single attacking aircraft, because even one getting through could sink a ship and kill hundreds of sailors. The pressure was immense, and the Hellcats and their pilots rose to meet it, shooting down hundreds of kamikazes, though inevitably some got through to strike their targets. The role of Hellcats in the final months of the war, had it continued, would likely have been supporting the planned invasion of Japan itself. Operation Downfall, as it was known, would have been the largest amphibious invasion in history, dwarfing D-Day in scale and complexity. Hundreds of carriers would have participated, carrying thousands of aircraft, including vast numbers of Hellcats. These aircraft would have been crucial to suppressing Japanese defences, maintaining air superiority over the invasion beaches, and supporting the troops fighting their way across Japan. The casualties on both sides would have been catastrophic, which is one of the reasons why the atomic bombs and the subsequent Japanese surrender represented such a profound relief to those who would have had to fight that invasion. The Hellcat's post-war career, while less dramatic than its wartime service, still merits attention. After the war ended, the immediate need for vast numbers of fighters evaporated, and many Hellcats were simply scrapped or sold as surplus. However, the aircraft continued to serve with the United States Navy for several years, flying with reserve units and training squadrons. Some Hellcats were converted for specialized roles, including target tugs for training anti-aircraft gunners and drone controllers for guided missile testing. Foreign nations that received Hellcats under military assistance programs operated them into the 1950s, with some seeing combat in regional conflicts. The French Navy, in particular, operated Hellcats for an extended period, using them during the First Indochina War in the late 1940s and early 1950s. French Hellcats flew from carriers operating off the coast of Vietnam, providing air support for French forces fighting against the Viet Minh. The ruggedness and reliability that had made the Hellcat successful in World War II served the French well in this different kind of warfare, though ultimately the conflict would end with French defeat and withdrawal from Indochina. The British also operated Hellcats for several years after the war, gradually replacing them with jet fighters as those newer aircraft became available and carrier-compatible. The transition from piston-engine fighters like the Hellcat to jet fighters represented a fundamental shift in naval aviation. Jets were faster, could fly higher, and had different tactical capabilities, but they also brought new challenges, particularly for carrier operations. Early jets were thirsty for fuel, reducing their range, and their high landing speeds made carrier operations more difficult. The Hellcat represented the peak of piston-engine fighter development, the ultimate expression of what could be achieved with that technology. Jets were the future, but the Hellcat had been perfect for its time, exactly what was needed when it was needed. In the decades since the war, the Hellcat's reputation has only grown. Military historians studying the Pacific War consistently point to the Hellcat as one of the key weapon systems that made Allied victory possible. Aviation enthusiasts celebrate its combat record and its role in the great carrier battles of the war. Museums around the world preserve surviving Hellcats, and a small number remain in flying condition, appearing at air shows where they demonstrate the power and capability that made them so effective in combat. The sound of that big radial engine, the distinctive profile, the knowledge of what this aircraft accomplished, all of it contributes to an enduring legacy. The men who flew Hellcats, those who survived the war and lived to old age, remained proud of their service and their aircraft until the end of their lives. Reunions of Hellcat squadrons would bring together men who hadn't seen each other in decades, and they would share stories, remember fallen comrades, and celebrate the brotherhood that combat had forged. These veterans understood, perhaps better than anyone else could, exactly what the Hellcat had meant. It had been their tool, their weapon, and often their salvation. It had given them a fighting chance when they went up against an enemy that had initially seemed unstoppable. It had brought them home when they were damaged and wounded. It had been the means by which they contributed to victory and helped end the war. The broader legacy of the Hellcat extends into the realm of industrial and engineering achievement. The aircraft demonstrated what American industry could accomplish when fully mobilized and focused on a critical goal. From the initial design to the final production aircraft rolling off the assembly line, the Hellcat program showed that American engineering could produce weapons systems that were not just adequate but world-class, that could compete with and defeat the best that potential adversaries could field. This confidence in American technical and industrial capability would influence post-war defense planning and would be a factor in the Cold War that followed World War II. The design philosophy embodied in the Hellcat, prioritizing ruggedness, reliability, and ease of use alongside raw performance, influenced subsequent generations of American military aircraft. The idea that an aircraft should be a complete package, effective in the hands of average pilots rather than only accessible to extraordinary ones, became a principle that guided many later designs. The focus on survivability, on bringing pilots home even when their aircraft were damaged, became standard practice. These lessons, learned and applied with the Hellcat, saved lives and increased effectiveness in later conflicts and continue to inform aircraft design to this day. Looking at the complete picture of what the Hellcat achieved, the numbers are almost overwhelming. More than 12,000 aircraft produced, more than 5,000 enemy aircraft destroyed, a kill ratio of 19-1, service on every American carrier in the Pacific, participation in every major campaign from 1943 onwards, countless missions flown, countless lives saved, countless tactical victories achieved. These statistics, as impressive as they are, still don't fully capture the significance of what this aircraft meant to the war effort and to the individual pilots and sailors whose lives it protected and whose missions it enabled. The Hellcat succeeded because it was the right aircraft for its specific mission. It wasn't trying to be everything to everyone. It was designed to win air superiority over the Pacific and to do it from aircraft carriers, and every design choice was made with those specific requirements in mind. The result was an aircraft that excelled at exactly what it needed to do, without unnecessary features or capabilities that would have complicated production or reduced effectiveness in its primary role. This focus, this clarity of purpose, was itself a key factor in the Hellcat's success. The story of the Hellcat is ultimately an optimistic one about human capability and ingenuity. When faced with a desperate situation, when confronting an enemy that had technical and tactical advantages, American engineers and industry responded by creating something better. They didn't just match the threat, they overwhelmed it. They produced an aircraft in record time that proved superior in combat and that could be manufactured in the quantities needed to achieve victory. They equipped that aircraft with the weapons and protection systems it needed to be effective. They created training programs that produced pilots who could use the aircraft successfully. They established the logistics networks that kept the aircraft supplied and maintained in combat zones thousands of miles from home. All of these achievements, technical, industrial, organizational, tactical, came together in the Hellcat and in the broader system of which it was a part. The aircraft itself was crucial, but it was just one element of a larger whole that included the carriers from which it operated, the support ships that protected and supplied those carriers, the intelligence networks that provided information on enemy movements, the training establishments that produced pilots and maintainers, and the factories and workers back home who kept the whole enterprise supplied with what it needed. The Hellcat's success was thus a systemic success, the result of an entire nation mobilized for war and focused on achieving victory. That victory, when it came in August 1945, meant different things to different people. For those who had fought in the Pacific, it meant an end to the terrible combat, an end to the constant danger, a chance to go home to families and 2 lives interrupted by the war. For the Hellcat pilots and crews, it meant they had survived, that the odds had finally come down in their favor, that the aircraft they had trusted had indeed brought them through to the end. The relief was overwhelming, mixed with grief for those who hadn't made it, and with an awareness of how close they had come to not surviving themselves. In the grand sweep of history, The Hellcat occupies a specific and important place as the fighter that gave the United States air superiority in the Pacific during World War II. This might seem like a narrow or technical achievement, but its implications were profound and far-reaching. Air superiority enabled everything else: the island-hopping campaign, the destruction of Japanese shipping, the eventual bombing of Japan itself. Without it, the Pacific War would have been fundamentally different, longer, and far more costly. The Hellcat provided that air superiority through a combination of technical excellence, overwhelming production, and effective employment in combat. It was the tool that accomplished the task, and it accomplished it with a thoroughness and effectiveness that exceeded all expectations. The physical aircraft themselves, those that survive today in museums and private collections, serve as tangible reminders of this history. Standing next to a Hellcat, you can appreciate its substantial size and rugged construction. You can see the 6 gun ports in the wings, imagine the firepower that represented. You can look at the cockpit, cramped by modern standards but functional and well-designed for its purpose, and think about the young men who sat there and flew into combat. You can see the folding wing mechanism that allowed carriers to pack more aircraft into limited hangar space. You can examine the landing gear, massively strong to absorb the punishing impacts of carrier landings. Each physical feature tells part of the story of what this aircraft was designed to do and how it did it. For those who want to truly understand the Pacific War, understanding the Hellcat is essential. It wasn't just a piece of equipment, it was a key enabler of American strategy, a weapon system that changed the balance of power decisively. Its development, production, and deployment represented American industrial might translated into military capability. Its combat record demonstrated what could be achieved when superior equipment was combined with effective tactics and well-trained personnel. Its legacy influenced post-war aviation and defense planning in ways that are still felt today. The story of the Hellcat is one that deserves to be told and remembered, not just as aviation history or military history, but as an example of what human beings can accomplish when faced with existential challenges. The engineers who designed it, the workers who built it, the pilots who flew it, the ground crews who maintained it, all of them contributed to something larger than themselves, to the defeat of tyranny and the preservation of freedom. The Hellcat was their tool, their creation, their legacy. It did what it was meant to do with brutal efficiency and decisive effect. It turned the tide in the Pacific Air War. It crushed Japanese air power. It enabled victory. That is its story, and it is a story worth remembering.